before we get started, I'm going to give you a brief introduction to serverless technology. Just an overview of what we're going to do today. First, I'll introduce serverless, tell you all about what serverless is. Then I'll do a brief introduction to Azure Functions. Then I'll go through a demo of doing out-of-the-box intelligent applications. So Azure provides a lot of technology that helps you get started very easily building applications, particularly intelligent applications. So we're going to go through a cool demo there. Then we're going to go into a more detailed example of what you can do when the problem's a little more complex, maybe custom to your company. And we'll go through how Azure can help you there as well. So without further ado, what is serverless? In order to tell this story, I'm going to go through kind of the history of the evolution of cloud development. So before the cloud, everything was on-premise. We had to deal with a lot of things ourselves. We had to buy machines. We had to physically operate on them. We had to upload our code. We had to manage the physical security of our data centers. With the advent of the cloud, all of these things went away. So that was on-premise, and then all of these things were supposed to go away. With IaaS, however, what we got was actually management of our logical infrastructure instead of management of our physical infrastructure. So you still have to think about all of these questions. How do I patch security vulnerabilities? How do I deploy my code? How many VMs do I want to run on? All of these are things that you still have to think about as an application developer. So that was the move to infrastructure as a service. One more step in that direction is platform as a service. So with platform as a service, you as a developer have to think much less about the infrastructure. We handle all of the underlying things for you. So for instance, rather than saying, I have full control over this virtual machine, I do everything on it, you say, I would like 2 VMs, please, and then Azure handles the rest. A really great PaaS service that Azure has is Azure App Service. Shout out to Jen, who gave a great session yesterday on Azure App Service. Anyway, the distinction here is that Azure is managing the platform level for you. And since Azure Functions is built on top of Azure App Service, we get a lot of really robust platform features from there as well. And moving one further step in the direction of abstraction is serverless. So serverless, you don't even have to worry about the scale of your application at all. So rather than even saying, I would like 2 VMs, you say, here's my code, here's my application, I would like it to run. And whenever it runs, it runs. You don't need to worry about anything further than that. You don't have to manage any of the infrastructure yourself. So that brings us to our kind of core definition of serverless in 3 pieces. 1, it is the full abstraction of servers. So you as a developer don't have to think about any of it. You as a developer focus only on what's unique to your business. You write your code that is business logic. You don't worry about infrastructure management. Next, it is the event-driven instant scale aspect of serverless. So everything with serverless is based on events. I have an event come in, it triggers something happens, and when many more events come in, many more things happen. And all of it scales dynamically on the fly for you. Last is pay-per-use. So as you can imagine, if we have a system that scales dynamically, it's impossible for us to bill you based on a flat rate for the infrastructure because the infrastructure is changing all the time. So we bill you based on what you actually use. And what this means is that if you have an Azure function or an Azure Logic app or any of our other serverless technologies that isn't being executed, it just sits there. You don't pay for anything when it's not being executed, which is really, really powerful, and a lot of people, a lot of our customers really, really appreciate that. For instance, if you have something that's executing once every hour, you pay once every hour. So I think the value proposition there is pretty clear. So it wouldn't be Microsoft if we didn't have a really robust platform fleshed out around all of the serverless components. At the core of our serverless platform here in Azure, we have 3 main services: Event Grid, Functions, and Logic Apps. So I talked a little bit about eventing. I talked about how all of the kind of core of serverless in Azure and elsewhere is reacting to events. So Event Grid is the solution that lets you manage those events. It's kind of the eventing backbone to our serverless platform. Functions is compute. So Functions lets you run one small piece of code that will react to events, do whatever you need to do, expressed in code. So the possibilities are endless. And then Logic Apps lets you do visual workflows and orchestrate processes. And the really cool part about Logic Apps is that it integrates out of the box with over 200 first-party and third-party services. That being said, other than those 3 services, we have many other Azure services as well that play very nicely with the rest of the serverless platform. So while these services like Stream Analytics, AAD might not necessarily be considered serverless themselves, it's very easy to layer them with other parts of your application to build a serverless application. One of our other things that we're really proud of, and I think we do very well here in Azure, is the local development support and the kind of just entire developer ecosystem. We have out-of-the-box support for Azure Functions with Visual Studio and Visual Studio Code. We have a command line interface called the Azure Functions Core Tools, which lets you very easily use Azure Functions in whatever IDE you'd like. You can develop anywhere and then via the command line deploy and kind of do your management operations. And then, yeah, we go from there. Also, we have really great DevOps integration with Azure DevOps, which is recently rebranded from VSTS. So I think I'm still allowed to say VSTS. But also, one other thing I'd like to highlight is with Application Insights and some other technologies in Azure, we have really great, robust monitoring solutions as well. So you can know exactly what's happening with your code, even though we are managing it. So let's get a little bit more in depth into what actually Azure Functions is, because we'll be introducing it later on, and it builds on some core concepts that you should be familiar with. First, we have events. So events are the source. It's what triggers your application. This can be many, many different services in Azure and some outside of Azure as well. But the main things you would need to worry about are, well, the main things you can build your applications with are these triggers. So the first thing you need to think about is what's triggering my function. And then once you have that figured out, you can build the rest. So example triggers are HTTP. You can have a webhook call your function. You can have a timer. You can have many different Azure services, such as if you, say, upload a blob to blob storage. And from there, your code executes. So your code is whatever you express. You can write your Azure functions in C#, JavaScript, and some other languages as well. We'll get onto that later. Then we have this really great model, this programming model that we're really proud of, bindings. So with your function, you have one trigger, and then you can also have input and output bindings. So what this does for you is it lets you worry about in your code only the actual piece of logic that you need to write. So we'll go and handle negotiating with other SDKs, we'll go and fetch resources for you, and then we'll go place them elsewhere as well. It makes it very easy for you to write code because the only thing you have to worry about is what's actually happening, what's actually unique to your business. You don't have to worry about, say, fetching a blob from blob storage because we handle that for you. So let's move on to intelligent applications. That's why you're all here. What's the definition of an intelligent application? Very broadly speaking, it is any application which takes advantage of machine learning or artificial intelligence. Now, that's an incredibly broad definition. And I keep it very broad intentionally because really the scope of what you can do here is pretty limitless. Anything which takes advantage of machine learning or AI is an intelligent application, which means that with the help of a lot of different services that we have here in Azure, you can build some of these yourself. So first, I want to highlight two examples of intelligent applications just to give you some inspiration, I guess. The first is this picture here on the left, which is a woman using Cortana. So Cortana is Microsoft's speech recognition software. You can call out to the Microsoft Graph. You can basically ask it questions in real time. It'll go and figure out things about what you're doing later in the day, for instance, or do a search for you. And it's a really, really powerful technology. And as you can imagine, it's completely built on artificial intelligence and machine learning. So that is obviously an example of an enterprise-grade, like very large-scale intelligent application. But the other example I have here is something that's much less large, I guess. I think that using these big examples of really powerful machine learning algorithms makes it seem infeasible for you and your company to, unless you're, say, like Microsoft or Google or something, to actually make intelligent applications. But that's not the case, because there are many places that you can introduce intelligence into your applications without actually having the entire core purpose of the application be intelligent. So for instance, I have on the right someone using PowerPoint. This is a presentation I am giving in PowerPoint. In PowerPoint, they recently introduced something in the Design tab called Design Ideas. And I think it's a really fantastic feature if you haven't checked it out. So what it does is you take a slide, you add pictures or words or whatever you'd like to say, you click Design Ideas, and then it automatically will format your slide. It'll give you some suggestions to make your slide more visually appealing for the presentation. This was super powerful because when I was first seeing it, it was, well, anyone can do this. You can have a designer go look through your deck, or you can spend a ton of time making things look good, or you can click this button and it will happen for you. So I think this is a really good example of a small feature within an otherwise not necessarily intelligent application that makes people's lives way easier and is a really good way to extend a piece of existing functionality. So let's now move into how Azure can help you with this. So I have here listed many of the different out-of-the-box services that you can stitch together. So up on the top row, we have all of the different cognitive services APIs. Cognitive services provides APIs for a lot of your, let's call them solved problems, things that people do many different times, like facial recognition or OCR, things like that. The thing is, with these services, we need something to consume them. We need something that can actually call the API. We need something that can, in the example of the other two logos, call out to Azure Machine Learning or the bot service. So Azure Functions and Logic Apps are a really nice fit here. Logic Apps particularly benefits very nicely from these connectors that I mentioned earlier. It has, again, out of the box, over 200 different connections, and I'll show off a few of them today. Functions also is a great fit here because, again, you can call out to really anything as you're in code. We don't necessarily integrate directly with as many of these services, but since you can call a function from a Logic app, you can do pretty much anything you want there as well. So even if we don't integrate directly with this in Functions, you can call out to it yourself, or additionally call out to it by integrating with Logic apps. So with that, I'll do a demo of this system I set up here. So let's flip over to my laptop. So Asavri and I recently, that's here. Is this me? This is me. There we go. It's going to be hard. I'm just going to duplicate. There we go. Cool. So Asavri and I recently started a company. It's called Contoso Mobile, or C-Mobile. As you can imagine, it's a very large telecommunications company, so we have many different things we have to worry about. And one of the things I first took on as a part of my work at C-Mobile was this support system. So in C-Mobile, we use Freshdesk, this ticketing system that helps us figure out what's wrong and kind of address customer issues. So as you can see, we have these two issues here. And what I've done is I've set up an application using Azure Logic Apps that integrates directly with this Freshdesk to parse my tickets. So when a new ticket comes in, it will parse the sentiment of the ticket. And depending on whether the person was very upset or very satisfied, it will increase or decrease the priority of the ticket and then send me a notification via Microsoft Teams either way. So let's go into Logic Apps and show you just how that works. So this is the Logic Apps designer. It's a visual workflow designer that lets you very easily integrate with many other services. So first, we have our trigger. The trigger, as you can see here, connects with Freshdesk. I didn't need to do anything other than enter my credentials for Freshdesk, and it automatically connected and maintains that connection through the duration of my development with Logic Apps. The only thing I had to specify here was how often I want it to check for new items. So I check every 5 seconds. Next, we have a call out to the Cognitive Services Text Analytics API. So I get from the previous step the description of the text that was in the ticket, call out to the Cognitive Services API, and it returns as a result a bunch of different things. And what I do is I have a conditional based on that. First thing I have to do for that conditional is actually change the string to a float. So Logic Apps makes that very easy. I'll go ahead and do it again on the fly by going down to expression, and I'll have to scroll down to, I could have just typed this, but float. Then I go back to dynamic content, and I find the thing that I actually want to make a float of. So let's say the score. So I want the float of the score, and then what I do is check whether that's above or below 0.5. So if it's less than 0.5, that means someone was upset. I know that my API returns a result between 0 and 1. So if it's closer to 0, then it's someone that is more negative. Right now, it's a pretty simple binary classification, but we could make this more complicated if we'd like later on. And what I do is then I go to here, which will, if it is true, if someone's upset, I will update the ticket with the same ticket ID with a high priority now. So I change this from whatever it was to high and keep everything else the same. And then after I do this, I post a message to Teams. Again, it was very easy to integrate with Teams. All I had to do was provide my connection information. And then I will post a message to this high priority tickets channel with the sentiment and the ID of the ticket, so I know which one to go look at. Or I know that a new ticket is there. In the false branch of the tree, I do the same exact thing, except I set the priority to low and send it to a different Teams channel, one that says low priority tickets. So let's actually see this in action. So I'm going to go over here, create a new ticket, and I first have to enter contact information. I will give you all my email. Oh, oops. There we go. Now I find me. And our subject is going to be, so do we want this? All right, let's do a show of hands. Who wants this to be a positive query? Positive ticket. All right, negative ticket. Subject, terrible presentation. And this, I'm going to keep it low priority because it'll get updated. And this was bad. Do better. So I'll create that ticket, and then we wait just a few seconds, and nice. I go over logic apps, and we can see here in overview or activity log, I'm not going to save my changes because it's exactly the same. I go into overview, and overview will tell me my runs. So here's the run that just happened. It succeeded, so let's go ahead and look at that. And just to prove to you before we do that, I'll go to my Teams channel, and it will be high priority tickets. And we can see a message that just sent today at 6:17 a.m. because I'm still set on West Coast time. Anyway, let's move back to the portal. So I've proved to you that works, and let's go through what happens in the logic app. So it tells me very easily that these steps succeeded. I created a ticket, I detected the sentiment, the conditional was true, and then this was a no-op, and the other side of the branch was successful as well. What's really easy with logic apps, though, is if you fail an execution, for instance, like, say, this run, you have right there in your details what actually happened during the run. So, for instance, here in the conditional, it's telling me that this is probably a little small on the screen, but what it says is the template function less expects two parameters of matching types. The first was float and string do not match. So obviously I had a typecasting error. The result of my API was a string, and I was trying to compare it to 0.5. So in order to fix that, I just went in, changed my logic app, add that little typecast that you saw at the beginning. But as you can see, it's very easy for you to debug what's happening in your logic apps, since we have a record right here of every run, what actually went wrong. So to summarize, that goes through an example of how you can, out of the box, build an intelligent application with logic apps very easily with all of these different connectors we offer, and from there make intelligent decisions that help improve your business processes. So let's switch back to the deck. And before we move on, I just want to go through one more time. What are the benefits of serverless? And let's think about how they apply here. So what are the benefits of serverless? Number one, it lets you focus particularly on your business problem. You don't have to worry about the underlying technology. I spent very little time when I was building this, or even on stage thinking about this. I spent very little time thinking about the infrastructure that was running my code. Everything was happening serverlessly. When I wanted, if many, many, many more tickets were to come in at once, this would happen automatically. The resources would provision by themselves. And that's really powerful, since I, as a developer, can spend the time writing code that's unique to my business and that I don't have to worry about infrastructure. Next, shorter time to market. Kind of in the same page, I didn't have to worry about anything, which meant I could develop faster. I could fail fast. I could move on to other services if I decide that I need more finite control. But for the beginning of my application, this worked, and this made it very easy. I was doing a problem that's been solved many times, sentiment analysis. I don't need to build a model myself to go make sentiment analysis happen. And then I could use these out-of-the-box services to integrate everything nicely. and make an overall application that works very well. Last, flexibility. With our serverless platform, we let you do many, many different things. So with Logic Apps, for instance, I could have done so many other things in my workflow. For instance, if I wanted to send an email or if I wanted to call some other API, I could have called an Azure function right from within Logic Apps. So we have all of these services that work very well together, which lets you build applications by layering them. Cool. So with that, I'm going to pass it off to Asaveri, who is going to tell you more about custom intelligence to your applications.
Great. Hi, everyone. All right. So far, we saw how you can add out-of-the-box intelligence to your applications using cognitive services connectors in a Logic app. But these actions were mostly standard actions. For instance, determining the sentiment on a customer support ticket is no different from determining the sentiment on a movie review or a restaurant review. What if you wanted to add more custom intelligence to your application that was more tailored to your business use case? Let's take a look at an example. At Contoso Mobile, we've been seeing huge customer churn over the last few months. We've had customers who filed several support tickets and have been unsatisfied and moved over to other cellular providers, or even those who've been experiencing a high rate of call failures and call drops and are almost on the verge of churning over to another service. The Contoso Mobile management wants us to build an intelligent application that can detect customer churn before these customers actually decide to leave the service based on different symptoms. So we can then run targeted promotions to incentivize the customers to stay on the service and continue on. What do you think about using machine learning in our application to build a solution? And since this is a serverless session, before getting into the very details of how I can use machine learning, I just want to do a little primer on what machine learning really means. Machine learning, or ML, is the process of examining huge amounts of data to recognize patterns and using those patterns to generate code that can make predictions on brand new data. These two components of machine learning are often referred to as model training and prediction. All right, so what does model training entail? The very first step to model training is finding a huge data set that's relevant to the problem that you're trying to solve. The more data you have, the more accurate your model's bound to be. Once you've got a data set, the next step is to go ahead and format it in the way that's acceptable or more relevant to your ML algorithm. Oftentimes, your data is bound to contain duplicates, conflicting information, missing information. You need to clean those out before you can actually start using this data set. And then finally, you need to identify a statistical algorithm that's relevant to the ML training process. Oftentimes, data scientists would go back and try different combinations of prepared data set and algorithms to find what produces the best or the most accurate model possible. And then finally, you can iterate on the model. As I mentioned, you can use different combinations of data set and model and training algorithm to find the best or the most accurate model here. Once we've trained a model, the next step is to use this model to run predictions against brand new input. Without deploying your model, all the work that we do to train a model is really just useless. And if you're not able to deploy the model fast enough, people who are building new models may not be able to iterate and test as quickly as they'd like to. Second step, for our inferencing application to be able to make predictions, it needs to fetch data from different data sources. It needs to be able to orchestrate with, for instance, a blob storage source or a Cosmos DB store to fetch data that we need to then make an inference on. And then finally, in order to make predictions in real time, I need my application to be based on events, to be invoked by events. Guess what? This is exactly the definition of serverless that we saw earlier in our session. Building your inferencing application using Azure Functions lets you really focus on the model training and the prediction code of your service and not have to worry about the underlying infrastructure or having to take care of the availability, uptime, or management of that server. Using the Azure Functions integrated programming model, you can use the inbuilt triggers and bindings to be able to speak with different sources to fetch input and then process that input for prediction. Finally, you can use the event-based nature of Azure Functions to be able to invoke your prediction logic based on an event that happens in a source system. And then you can also scale that prediction logic out when, for instance, when there are thousands of events that happen at once that you need to scale on. And then finally, we have one more requirement, which is oftentimes our traditionally models are usually trained using Python or R. They don't exactly have a straightforward API to be able to make predictions in a different runtime or language. It's recommended that you train and infer in the same language that you train a model in. We've got really good news for you today. Today, we're happy to announce that Azure Functions now supports Python. You can develop your applications using Python 3.6 on the Functions v2 runtime that just became generally available this Monday. Excuse me. You can publish your applications to a serverless hosting platform on Linux, and you can develop using the Azure Functions extension for Visual Studio Code or the command line tools that you're already familiar with. The Python and Functions feature is currently in private preview. You can sign up using the link on the screen, aka.ms functions Python preview, to try the latest bits and give us your feedback. Okay, with that, let's take a look at what this newly introduced Python service looks like. For the purpose of this demo, I'll be using the Azure Functions extension for VS Code to build my Azure Functions. This extension provides easy-to-use commandlets that I can use to create new functions from templates, create a new project, test it locally, etc. Let's take a look. I'm going to first go ahead and create a project in an empty directory and pick a runtime for my project. This will go ahead and generate a function project for me. It's important to understand that the function project is the equivalent of a function app in Azure, and it's the container that will hold multiple functions that share the same local and hosting configuration. When I create a Python functions project, Visual Studio also generates a couple of extra features for me. The first one is the requirements.txt file. This is the place where you can specify all your Python dependencies that you'd like to install to the environment in Azure, or if you're testing locally. It also generates a virtual environment for me that I can use to build and test locally. Now, I've got a functions project here going. The next step would be to go ahead and create an actual function in this project. When I try to create a new function, I've got the option of picking from a variety of trigger templates. Let's go ahead and pick HTTP trigger for our project. And I'll give this a friendly name. And you can pick the authorization level. Let's pick anonymous for the demo. Going back to our file system, what this did is in my function project, I have a new directory called hello. That's the name I gave my function, which contains two important files. The first one to note here is the function JSON configuration. This contains information about any of the data sources that you need to, that your function needs to bind to. We often refer to these as bindings. I've got two bindings here for my function. The very first one is an HTTP trigger, HTTP trigger of HTTP request type. And the second is an output binding, which is an HTTP response. I'll use the name parameters here for each of the bindings to bind this data to my actual Python function. Which brings me to the second file, which is the actual Python script. This is the entry point for your function. And will consume the input binding, which is the HTTP request, and produce an HTTP response as a return. Within my Azure function code, I can go ahead and use this data coming from the binding to manipulate it and run my logic, and then finally produce an output. This specific logic on the screen will look for a name parameter in the query string, and then go ahead and use it to print a hello name message. Since the Azure Functions runtime is open source, you can run it locally on your own machine before you even publish your functions to Azure. And with the capability that VS Code provides, I can simply go ahead and F5 into my function to start the functions runtime. So this already attached my debugger to my process, and I can see that it's created a localhost endpoint that I can use to trigger my function. Let's go ahead and set a breakpoint in my function right here. And then I can go ahead and start my function. You can see the breakpoint was quickly hit since this was only a hello world example. And then I can go ahead and provide a name in the query string to go ahead and finish the function. All right, so switching back, let's take a look at how we can use what we just learned, the newly introduced, fresh off the press Python support and functions to bring some value to the customer churn example we were talking about earlier. The very first step to predicting customer churn is going to be training a model. Training a model typically can take months and months of time or even years of research. Today we have a couple of minutes here, so I'm not going to be training a model on the fly, but let's take a look at how, what steps I can take to train a model, and then I'll use the results from a previous run in my Azure function. Today I'll be using the Azure ML Studio for data preparation and model training. I've already imported a data set, and this is an open data set from a French telecom company called Orange. It's a publicly available data set. I already went ahead and applied a few transformations to make sure that I get rid of any not applicable values, any duplicate information, and even information that's not really relevant to my training process. Once I've got the data prepped up here, I can go ahead and import it into my training experiment to actually use the algorithm to produce the model. The very first step, already spoke about this, we import the prepared data into my training experiment. Second, I can go ahead and now encode any columns in my data set that contain categorical information. This involves converting any of the enum values into information that's more tangible, more understandable to my machine learning algorithm. So that's the second step, encoding the data. And then finally, I can go ahead and identify a model, identify an algorithm to train my model. For this experiment, I used the Naives Bayes model to actually train my model using the data I had already prepared that you saw earlier. Finally, as an optional step, you can go ahead and test the actual accuracy of the model to determine if that's the right combination of prepared data and statistical algorithm that you want to use, and iterate multiple times until you make sure that you're finding the most accurate model possible. Okay. Now that I've got a model, let's talk a little more about how I can deploy this model and a prediction script as part of my Azure function. For the purpose of the customer churn example, we'll use customer input from a blob storage. I'll upload a CSV file to the blob storage and then consume that in my Azure function to run it against the model that we just trained and produce an output in the form of a determination whether the customer is going to be churning or not. Okay, back to Visual Studio. I've got a function project very similar to the Hello World example that we saw earlier. This one's a little different because it contains a function called predict that I have here. And I've added the model. This is the pickled model that we trained in the earlier demo. And I've added the model as a dependency to my function. I've got a function JSON, and this time it uses a blob trigger input to invoke my function. And then finally, the function script. We need to understand the function script a little bit more. It has 3 steps. The very first one is to initiate or load the pickled model into our function. It'll use the helper function right here, and you can see it's injecting the model that we'd added earlier as a dependency to the function. The second part is to go ahead and format the input data into a form that is more understandable by our model. We can go ahead and use a second function here, which is using the pandas library to convert our CSV data into a data frame that our algorithm would understand. And then finally, we can go ahead and use the actual prediction method that will encode our input and run it against the model to create a prediction. And then finally, we can go ahead and log our prediction to the console as a final output. Let's go ahead and run this application. Okay. Let's give it another try. Okay, I think I know what the issue is. Coming back. Let's start our function host now. All right, so my function, what this is, was started the functions, Azure Functions runtime and the Python worker. Now my functions host is ready and listening in on any events that might happen in the blob. So it can go ahead and process that input from the blob. Now we can go ahead and upload a sample input to the blob storage. I've got a customer record here which has some information about, again, the call failure, call drop rate, information about the monthly bill, and so on. I will go ahead and upload the CSV file to the blob storage so my function can start consuming it. And so this is an event that I was speaking of, an event in the source system that is capable of going ahead and triggering my function. And as you can see here, my function triggered and the prediction script went ahead and generated a determination. And as we saw earlier, a 1 means that we were able to determine that the customer is more likely to churn than not. So you saw how simple it was for me to train a model to write a prediction script and package those up into an Azure function to deploy serverlessly to the cloud. One of the pieces that I did not cover in this demo was publishing to Azure. The Visual Studio Code extension makes it equally easy to publish my function to Azure. And within Azure, we have a couple of hosting models available that Kobe will now be talking about in just a second.